This is part 1 of lecture 1.1 of Math 108, Introduction to Logic and Negation, Conjunction, and Disjunction. In this video, we will introduce propositions and propositional forms, which are two of the three types of statements that we will study in this part of the course. We will also look at propositions obtained using the logical operators of negation, conjunction, and disjunction. Part 1 of Math 108 is devoted to the study of logic. Logic is the branch of mathematics which deals with patterns of abstract reasoning. In the study of logic, we shall be interested in three types of statements, which are as follows. First are propositions. A proposition is a statement that is either true or false, but not both. The state of being true or false of a proposition is called its truth value. Second are propositional forms or propositional formulas. A propositional form is an expression consisting of variables that represent unknown propositions, together with logical operators such as not, and, or, and implies. Since a propositional form involves unknown propositions, it is neither true nor false, and so it has no truth value. Instead, it has a truth table, which we shall define later. Third are predicates. A predicate is a statement that contains variables that represent unknown objects, and that becomes true or false when the variables are replaced by specific objects. A predicate also is neither true nor false, and thus has no truth value. Instead, it has a truth set, which we shall define later. The following are examples of propositions. The sentence, "The number 29 is prime," is either true or false, but not both. So this is a proposition. This statement is true. This is the mathematical statement, "The principal square root of 16 is equal to -4. This is either true or false, but not both. So this is a proposition. This statement is false. This is the mathematical statement, "The limit of sine x over x, as x approaches 0, is equal to 1. This is either true or false, but not both. So this is a proposition. We know from calculus that this statement is true. The sentence, "Every even integer greater than 2 is the sum of two primes," is either true or false, but not both. So this is a proposition. Its truth value, as of the time of recording of this video, is unknown. The following sentences are not propositions. Any non-declarative sentence, that is, any sentence that asks a question, gives a command, or expresses an emotion in the form of an exclamation, is not a proposition. Such sentences are neither true nor false. The mathematical statement x equals 1 is not a proposition. Without any additional information about the unspecified object x, the sentence is neither true nor false. This is an example of a predicate. The sentence, "Condition P implies condition Q," is not a proposition. Since P and Q are unspecified statements, the sentence is neither true nor false. This is an example of a propositional form. Consider the statement, "This sentence is false." If this statement is true, then it is also false. And if it is false, then it is true. That is, if this statement has a truth value, then it is simultaneously true and false. This is an example of a paradox. Consider the mathematical expression, "The limit of sine x over x, as x approaches 0. This does not form a complete sentence, and so it is not a proposition. To further understand example number 5, let us recall the structure of a simple declarative sentence. A simple declarative sentence must express a complete idea. It consists of a subject and a predicate. The subject of the sentence is the collection of words that refer to the thing that performs an action or embodies a state of being that is described in the predicate. The predicate of the sentence is the collection of words that refer to the action done by the subject or the state of being of the subject. To determine if an expression written in mathematical notation is a complete sentence, it is helpful to read it aloud or to write it in words. For example, let us consider this expression, which we read as the limit of sine x over x as x approaches 0 is equal to 1. The words limit of sine x over x as x approaches 0 make up the subject of the sentence. It is the thing which embodies the state of being that is described in the predicate. The words is equal to 1 make up the predicate. It describes a state of being, namely equality to 1 of the subject limit of sine x as x approaches 0. Hence, this is a complete declarative sentence. On the other hand, let us consider this expression, which we read as the limit of sine x over x as x approaches 0. This collection of words refers to a thing, but we are not given any information at all about this thing. If we take this to be the subject, we do not have a predicate. Therefore, this collection of words does not make a complete sentence. This is why it is not a proposition. Note that it is possible for a declarative sentence to have a more complex structure. In particular, it may consist of smaller declarative sentences that are put together in a certain way. For propositions, this involves smaller propositions that are linked together using logical operators. We shall study propositions obtained in this way by looking at the underlying propositional forms. Recall that a propositional form has no truth value. Instead, it is a type of statement which describes the abstract logical structure of a proposition. There are 5 basic logical operators, namely negation, conjunction, disjunction, implication, and by implication. We will study each of these in the remaining part of this lecture. The following are the skills that you are expected to learn. First, given a propositional form, you should be able to obtain its truth table. This is fairly easy. Second, and much more challenging, given a proposition written in words, you should be able to identify the underlying propositional form. This involves the following. First, you need to identify the simple propositions that are inside the given proposition. Second, you need to identify the logical operators that are used to connect these simple propositions to each other. All of these skills will be demonstrated in each of our many examples, so be sure to pay close attention. We begin with propositional forms involving negations, conjunctions, and disjunctions. Let P and Q be variables representing unknown propositions. The negation of a proposition P is the proposition not P. We denote not P using a short horizontal bar as shown here. The proposition not P is true exactly when P is false, and not P is false exactly when P is true. The conjunction of P and Q is the proposition both P and Q. We denote the conjunction using an inverted V symbol, as shown here. The proposition P and Q is true exactly when both P and Q are true. It is false exactly when at least one of P and Q is false. The disjunction of P and Q is the proposition either P or Q. We denote the disjunction using a V symbol as shown here. The proposition P or Q is true exactly when at least one of P and Q is true. It is false exactly when both P and Q are false. For example, suppose that the proposition P is the number 29 is prime, and the proposition Q is the principal square root of 16 is equal to -4. Not P is the statement the number 29 is not prime. Not Q is the statement the principal square root of 16 is not equal to -4. This is written in symbols using the not equal sign as shown. P and Q is the statement the number 29 is prime and the principal square root of 16 is equal to -4. P or Q is the statement the number 29 is prime or the principal square root of 16 is equal to -4. For clarity, the English word either is used before the first word in the disjunction. Thus, we write either the number 29 is prime or the principal square root of 16 is equal to -4. It is possible for a propositional form to involve more than two propositions. In this case, we use parentheses and other grouping symbols to signify which combinations are to be treated as a single statement. For example, consider the form not P or open parentheses, P and not Q, close parentheses. In this propositional form, the conjunction P and not Q is inside grouping symbols and thus is taken to be a single statement. We then read this as the disjunction of the statement not P and the statement P and not Q. The corresponding proposition is the number 29 is not prime or the number 29 is prime and the principal square root of 16 is not equal to -4. For clarity, we add the word either before the first statement in the disjunction and a comma before the connective or. Thus, we write either the number 29 is not prime, comma, or the number 29 is prime and the principal square root of 16 is not equal to -4. This is the end of part 1 of lecture 1.1. The discussion will be continued in part 2. Thank you for your attention.